Hi, hello guys, good morning. Can you hear me?
Yes.
Okay. Uh-huh. So before before we start our third lecture this week, third week, I have announcement. Last week I informed you guys for this course object OOAD, we don't have examination. We will assess your mark 100% based on your assignment. But actually, I think I misunderstood from some courses. For your courses, for your subject, OOAD, for these courses, you have examination, which will contribute 50% of your assessment. So that's mean assignment 50, examination is 50%. Okay, so you have examination. Yes, 50-50. I already post this in the classroom. Here, I already post here. Assignment 50, examination 50. So for your assignment, or for your marks, what I can do or what I can help you guys is with your assignment here, 50%, half of your mark, because assignment for assignment, uh, we have like a weekly progress. So I think for assignment we can do our best to score for highest mark. But for examination, since I'm not the course coordinator, I'm not the one who provide your lecture and your lecture note. I mean your lecture note or any material for these courses, included your exam paper. So I'm not sure about this paper. I'm not sure what kind of question they will ask you. I'm not sure what is the question because the lecturer from Penang, if I'm not mistaken, the lecturer from Penang who designed the paper for you guys. So for examination paper, there's nothing I can help you with. But yeah, you need to, because it's an open book, right? Because it's open book exam. So I think, but for examination, right, for open book, because I designed or I have one paper that I designed the exam paper. Yeah, I designed the exam paper. For open book, you need to understand the concept of the question. You don't waste your time to Google the scenario test. You don't waste your time to Google the question because the question cannot be found on the internet on the Google. So don't waste your time to Google. So understand the concept, apply the concept to the question. I'm not sure which question or which chapter they will ask you for exam because I'm not involved in the question paper. And then that's one thing. And then for second thing, for your attendance, right? For your attendance, because last week, I'm not sure what's the problem with the Google Meet because actually after our Google meeting ended, a report will be sent to me. I'm not sure if it is sent to you guys too, but it will send to me the attendance list for for the class. So, but last week I think there's one problem with one of my student. The Google Meet didn't capture her email address, so she was considered absent last week. So I want you guys to check your attendance and inform me if you have any kind of problem. Because if you have less than, if I'm not mistaken, 80% of your attendance, you will be barred from the exam. So you need to check your attendance. Okay. Think yeah, that's all. So for the examination and your attendance. So any question before we start our lecture? No, not this one. Okay, let's start with our, let's start from where we stopped last week. Okay, so yes, I heard something.
Don't forget to record. Oh.
Okay, so last week oh, where is it? Last week we learned about waterfall model and then we touched about a bit about USDP, Unified Software Development Process. Mm, USDP, and then here we stop here. So here in this USDP, let me start from here. For a USDP, there are there are four concept. There are four phases that you need to understand, or you need to understand. The first one, inception, elaboration, construction, transition. This one I already explained last week, but mm, yeah, this one I already explained last week. Regarding your exam, I'm not sure the question again, But if I think this is not your first time sit for the open book examination, right? But for open book examination, the question or the paper won't ask directly. They won't ask you at for your level. They won't ask you directly what is the or list out the phases for USDP or list out the phases for waterfall model. But they will like give you a situation, or yeah, they will give you a situation, and then they will ask you what is your understanding or how can you apply this concept, for example, this concept or these phases of USDP into the question. So you need to understand the concept. So this one I'm not yeah, this one I already explained last week. So this is where we stop. So as you can see here, this is the because the keyword for USDP is iteration. Iteration is a repetition. So for USDP, they allow a repetition in the phase. So as you can see here, this one is the same with the next here, with this with the next figure here. Okay, as you can see here, this is like a step, requirement analysis, design, implementation, and test. So this is the phases in the USDP. As you can see, there are four: inception, elaboration, construction, and transition. So as you can see here, there are explanation on the explanation here, size of square relative to time spent on workflow. So the square here is the time spent on each of the phases that, or the time spent that the time spent on each of the phases. That means how long the or how long the time you can spend for the iteration, or on which phases you can see on which phases that they spend the most on the iteration. For example, here we take this one, inception, on the second phase for the requirement gathering, requirement capturing. So they spend most of the time, it's not most, they spend more time here on inception, on the requirement gathering. For your, again, for your exam, I'm not sure, but I don't think you need to memorize this figure. But you need to understand for each of these phases, or for USDP process, is it or from any question or any situation that they given, you need to identify which of the phases that they spend the most, or they can do the iteration or repetition. As you can see here, for transition, right, there's no mark here. That means they don't do any iteration on the requirement capturing or requirement gathering for transition. So yeah, this is the process or the time spent for USDP. So compared to the waterfall model last week, it said that the waterfall model is not the best practice for us to apply. Compared with USDP, it is can be considered as best practice. Best practice. There are three that they list out here why it is considered as best practice. The first one, the iterative and incremental development. Compared to waterfall, the USDP allowed the iterative and incremental. That means if you already pass one phase, you can go back or do repetition on the previous phase. And then major requirement, for example, here you already on the design phase, you already here on design, but there are still function adding of requirement. So they let you or let the user to, not the user, they let us to go back to add the any functionalities, and they're developing using prototyping. Prototyping is anything that they can change, or any product that do before the final release or final vision of their product. So before releasing the final product, they're using the prototyping so that it's more flexible for us, for them to do any changement to the requirement. Any changement is like adding more functionalities. And then break the project into small sub-project. Okay, instead of delivering the project or the system as one whole system, using USDP, we can deliver using sub module or sub project. I think it's more to sub module. That's mean for one whole system, we they deliver or we use this USDP to design as module by module. That's mean we focus on one module or one sub module first, and then we deliver we deliver it, and then only we deliver in the one fully functional system. Instead of delivering it together as one functional system, we break into small or sub module or subsystem. So the second point is component based development. This one, the one here, that's mean instead of one whole system, they break and they build the component by module first, and then they combine by component. They combine the component together to be a one whole system, one complete system. Requirement driven development. Driven development is a process where in the middle of your like let's say in the middle of designing or in the middle of any process, the user suddenly come to you and tell you that they need to add more functionalities, or they want to add more requirement. So this USDP allows the user involvement is extensive. And then for another example is if they already complete one sub module or one sub module. So usually we will show to the client or we will show to the user if the module if is what they requested, and then they will check the module to see if the requirement is already there. So they are involved for each. I would say they will involve for each module to make it a complete system. So any changes or anything that they want to implement, any new functional requirement, they can involve. They are involved. The user are involved with the process. That's what it's mean by requirements driven development. And then again, or yeah, again, here is the continue for the previous page. Why the USDP is considered best practice because of the configurability. Configurability, like I said just now, before we release before we release the final version or final product, before we release final version or final product, we have like a prototype. So for each prototype, uh, let me just show you example. Usually when we develop or design a system, for example, this system A, system underscore A, and then 2021 So for example, this is the version. So for example here, as you can see here, this is the version of system A, any system, the year, month, and week, July and week. So for example, we are in a progress to design a application or system. So let's say we already done the first module on first sub module on this version, the first version of this month for this year. So after we already complete this version, after we already complete this version and we show it to the to the user, then they said that they want to add some function or they want to remove some function. So we come out with this version, and then um, after we already done this module again, we show it to them, we show it to the client or to the user, the system or the latest version of our product, and then if they said they still need to do there are still some changes need to be done, then we will produce a new prototyping, and then the meaning of configurability here, based on this prototype or based on this release version, we can configure anything or any changement that they want until the final product is released. Let's say they already done, this is the final product, the final version of our product. So we will release this to the user. So that's why USDP is considered as the best practice, because we can have this version, and then um, we have different version of control. This version of control is very important, because if you want to see, for example, you already come up with this version, right? The final version, and then suddenly they said, the previous version is good compared to this version. So that's why for every version of your project or every version of your design, you need to keep them. Even when you're working, this is very important, because even you already delivered to the client or user, sometimes they ask you to revert back to the previous version. So that's what we call as version control. Yeah, version control. The next one is architecture centrism, structured design into package components. This is more to like we break the system into sub module. No, we break the system into module, or we can call it as package. Package is anything that you group together. So that's mean under one package you can do one module, components and deployment. So you're focusing on one module and then you do the deployment for that particular module. And then visual modeling technique. Using this USDP, you can apply your UML in SAD. Because, but for this one, visual modeling technique, not only for USDP, but for the previous method or previous model, what was it? Waterfall, you can also apply UML in SAD, not only for this development process for UML in SAD. Okay, this is as you can see, this is the development cycle for your project. So as you can see, this is the four phases. This is the four phases of USDP. And then first is the milestone. Milestone is, like I said, usually for project we use Gantt chart. Yeah, we use Gantt chart. So milestone decision point where some significant design revision occurs. So why in the milestone, or in our planning, in early phase of our planning, uh usually iteration endpoint when some significant decision or revelation occurs. Usually after we already design, or we already complete this phase, before we do or we move to the next phases, which is construction. After we conclude, because for each phases we need to conclude. So after we conclude or after we conclude this phase, sometimes we can see the gap or the issue or any, yeah, I would say the gap for your phases. So sometimes you still need to do iteration on your, even like planning of your project. Even on the planning part, you still need to do iteration if there's any need to do iteration or changement. So that one is on the milestone. And then the second part here on your construction, This is the release. Release, I think you can understand from the term construction, where we release a stable executable subset of the final product. That's mean this is where we release our final version of our product. But before we release our final product, of course, there will be, like in the previous batch, there are like prototyping, final different version of your product. But always at the final product or your final version of your product, the end of each iteration is minor release. Minor release, that's mean mm, the end of each iteration of the minor release. Because minor release is like when you almost come to, I won't say that's the end of your product. It's like when you almost come to your final version or last version of your product. So that's the meaning for here, the release function, the release phase under the construction, and then increment, the difference delta between the release of two subsequent iteration. Increment, the difference between the release of two increment, different delta. The difference delta between the release final product. I think this is increment. Here increment delta. So two. I don't understand what is the significance of this part. So I'm not sure what's the delta. Is it the delta version? Beta. I'll explain this. I'm not sure what does it mean by delta here. So the last part is a transition, final product release. This is the final product of your version. Here, here. Yeah. This is the final product of your version before you release to the user. What is delta? I'm not sure. I'll get back to you guys on this. I'm not sure what it meant by delta. Subsequent iteration. Subsequent iteration. I'm not sure this one. So basically, this is the process. You need to understand each of the phases, or you need to understand how to apply this concept, based on your situation or any question given to you. Yes. Mm, Phase workflow and yeah. With USDP, again, like I said, for normal process, same with the waterfall last week, we have planning, analysis, design, implementation, PADIM. For waterfall, we have five basic phases, which is planning, analysis, design, implementation, and maintenance. Same goes to USDP. But the last part is this one. This is the only different with waterfall. Requirement can be considered as planning, planning or requirement capturing, analysis, design, implementation. This four phase is same with waterfall. The only difference is the last phase, which for USDP is test, but for waterfall is maintenance. So that's the basic workflow or the basic phase. Yeah, like I said just now, the balance of effort spent in each workflow varies from phase to phase. That's mean in each of these phase for USDP, the time that you spend or the iteration or the repetition that you do is different based on the needed of the phase, or yeah, based on the needed of the phase. Here it's said that within phase there may be more than one iteration involved. It can be one or it can be none of the iteration involved. So it's different from each phases. Okay. Mm, an iteration. So here you can see this is the workflow, core workflow for USDP. You have requirement of planning, analysis, design, implementation, and test. So the iteration happen or occur here in design. Design is a phase like I explained last week. Design is a phase where the mm, where your construction and your testing occur. No, no, no. Testing is not occur here. It's construction of your project. So we just have five core workflows. Yeah, we can see the iteration occur here, but it's depend on your phase. Sometimes it can have one iteration or it can have more than one or none iteration occur. So this is the basic workflow. Yes, Noel, isn't increment is like improvement, like, yes, like, yeah, increment occurs or iterative will take place if there's a requirement or anything that user requests. It will be to improve their product, but sometimes you need to know that for iteration or improvement for your what we call it, for your project doesn't mean improvement is like adding functionalities. Sometimes improvement or iteration can be done to remove or to remove any function that they think doesn't longer significant to their project. So increment, the purpose of increment is to improve their version. Am I answering your question, Noel?
Yep.
Okay. So here applying it. Okay. Here is the here uh, the one that I explained just now, iterative approach, any subset of perform several times to better understand. So why does iterative or why do we use iterative approach for this USDP is because to improve better understand of the requirements and gradually develop a more robust system. Robust system, if I'm not mistaken, robust system is a system that mm, develop a more robust system. Wait, I forgot already what's robust system. Wait, Mm. Oh, so robust system is the ability of the system to adapt or to adjust with the any occur that any bug or error that occur. So iterative is to it's like a iterative approach is for better understanding and to provide what's the term used here? Yeah, it's like improvement for your project. And then is iteration. So any repetition or any changement you do to your phase, to your project in any phase is called as iteration. And a series of system. Yeah, I think this is what I said throughout this lecture. So iteration is like any change or any change to any phase that will come out or result in final system or final product. So this enable user better understand the requirement and gradually develop a more appropriate system through successive refinement and increment. I think this is all you can read because I think the point here is all the same. Iterative development allow the user to have a better understanding to produce or to come out with before we come out with a final version of product. So I think these 3 points here conclude that part or that point. So we move to here. So this is the process milestone. So this is the this is the how can we see what's the relation between this phase or how the iteration can occur and what's the phases in the workflow. So as you can see here, the milestone, life cycle objective, architecture. This is like the milestone here is like how do you say this? The milestone here is like mm, life cycle architecture. What's the term? It's like it's not like I think this is the process. No, no, what's the term? It's not the phase. I think this is I'm not sure what's the term, but for each of these milestone, you can see for the first one, inception is like I forgot already what's the term for each of these. It's milestone, but process. It's not process. Mm-hmm. I forgot already. Just one term. Yeah, let's use it milestone. Okay, milestone. So as you can see here, for each of these milestone, it intercept or it is used for each of the phase. As you can see for USDP, there are four main phases: inception, elaboration, construction, and transition. So the I'm not sure how to explain milestone with you guys, but I forgot the term. But that's the phases and then the iteration. For example, in inception, iteration. For example, here in this phase, there are one iteration. That's one iteration, the basic workflow or the basic like under iteration, there are phases like how to explain this now. Okay, for example, iteration, like I said just now, for each of the phases, there can be different or it depends on the requirement or the needed of the iteration to occur. For example, here, inception here, only one iteration, aberration two and one. So it depends on each of the phases, but each of the iteration, you need to know you need to understand the concept. What is the workflow or what is the phases that include for each of the iteration process. Are you guys understand or not? Highlight? You mean this one? I'm not sure what's the term, but I think I don't remember what's the term, but I think there's one word that I can explain or I understand with this term. Never mind this one. But you need to understand for each of the phases, the number of iteration can be different. And then for each iteration, you need to understand the phases that or the workflow that take places, which is requirement gathering, analysis, design, implementation, and test. Okay, I think that's for this batch. I think this figure is only want to explain yeah, how can we relate them. Yeah, this figure only want to explain how can we relate them. Okay. This is another example for or explanation of iteration and incremental development. For example, here requirement design. For example, here requirement design, time design. This is iteration, time design, final iteration, iteration of fixed inline. This is iteration system iteration. Hold on, a class. This is iteration time, feedback from iteration, loads, increment, and feedback from iteration leads to refinement and adaptation of the requirement. Oh, okay. I think you understand. As you can see here, okay, let's focus on this one first. This is requirement design implement. Requirement design here is the process requirement design implementation and final integration or system test. So This is the mm, 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 mm. Or let me conclude this whole process for you. Okay, this process is trying to tell you that uh, you can read from here. Feedback from iteration or feedback from iteration leads to refinement and adaptation of the requirement and design in iteration n+1. Okay, that's mean here. Each iteration will come out or will produce a better, oh no, a new version of your product. A new version will come with the new requirement and design iteration n+1. I think this is how I explain. Here from this, okay, for example, let's take this version. So for each of these phases, oh, not phases. So for each of this version, the version is come from, like I said, I think I already explained just now. This version is adding or is, what's the term? Yeah, increment. No, this version is no, salah. This version is like improvement or they are enhancement from this previous version. So this previous version, like I said here, they are already like increment iteration from this project. I mean, from this project, they are iteration or how do you say? From this version, they are iteration that will lead to this version. So that means this version is enhanced. It's not enhanced. It's like for example, if the user want to request something, this is the latest version that they come based on this iteration. That's the whole meaning of this whole figure here. But the last project or the use of increment or iteration will only produce with one final project or one final product. As you can see here, the system grows incrementally. That means your final system or your final product will grows as you do more in iteration. Because do you understand what I'm trying to say? What I'm trying to explain? Because, or do you have any question?
No.
No, I'm not sure how to explain, but as you can see here, the system grows incrementally. So that means after you do more iteration, your system is closer to the final version that the user expected. That's the meaning for this whole process. Okay, I'm not sure how to explain. Okay, let's move why we use iterative development or what's the benefits of iterative development. So learning within an iteration. Like I said, here in this vision, learning within an iteration, that means you will understand the requirement or you will understand what the user want if you do iteration. From this version is better than this version. That means your iteration can improve your understanding of your project or your product. And then manage complexity. Manage complexity is because, like I said, using USDP, we break the system. Instead of delivering one whole system, we break the system into sub-module. So we can manage the complexity of each of the module instead of the one whole system. Manage changing requirement. This is so obvious because we do iterative because there's some changing requirement. If there's no requirement from the user, then that's our final product. So iterative allow the user to give response and to, it's not to give response, to request for any addition requirement. And then provide partial solution. Partial is like referring to this manage complexity. We break the system into submodule. So provide partial solution is like when you have one complex system, we can break them and then we can, how do I say? Partial is like, I think you understand the terms partial, right? So we can relate the terms partial. It's not that we relate, it's like we're breaking the system into submodule. That's mean we can focus on the particular module and we can provide any solution to the complexity of the module. Yeah, that's, I think that's the definition here. So feedback from user, like I said, instead of delivering the whole system, we show the system in the package or in the sub module. So if they have any comment, they can comment or any requirement they can give back to us. And yeah, so that's why I think there's in previous slide user, I'm not sure what's the term, but that's meaning that the user is mm, the user requirement is it's not the user requirement, feedback from user. That's mean for each module the user can give feedback, so we can change any of the module. Yeah, we can change any of the module instead of delivering the whole system to them. So that's the meaning feedback from user, because the iteration is allowed, so they can change anything at any phase. And then in okay, this is so incremental development. So iterative process is incremental because we don't simply rework the same requirement in successive iteration, but address more and more requirements in successive iteration. That's mean for this point, iterative process is incremental because we don't use the or we don't do the same increment, or we don't, if the version is already, or if the requirement is in, for example, here, if the version is already here in this version, we doesn't need to do more incremental for our, we doesn't need to do iterative. There's no iteration for this system unless there are more requests. So we need to add one more version, or we need to include, or we need to add one more version. So we doesn't simply rework the same requirements successive iteration. But like I think Noel asked just now, the incremental is like what's the term? It's like the improvement of each of your product. Right? The longer the time, the steeper the development rate. What does it mean? Or which part, Noel? The
No,
longer the time,
previous like
previous, the longer the time, the steeper the development rate. Development rate. Development rate. The longer the time.
because incremental, right? That's how I
What do you,
understood.
I don't understand
Like
what is development rate.
the longer the time, the bigger the development speed, like the progress, like more effort.
Oh yeah, I'm sorry. Yes, I mean yes. The longer the time, the steeper the development rate. Yeah, be- yeah. The answer to your question is yes. So this one just now, yeah, we're adding more version because we want to address or we want to include more requirement in successive iteration. Likewise, activities may occur in parallel within a single iteration. Okay, for this one, activities may occur parallel within a single iteration when they focus on different parts of the system and don't conflict. So that's mean, like I said, or yeah, as explained, we break the we break the system into submodule. So into that submodule, if I think the explanation here is like they are developing or they are it's not developing. They are doing the submodule simultaneously, concurrently. Oh, what's the yeah. Parallel is like simultaneously or concurrently. So they develop or they design the module concurrently, but within a single iteration when they focus on different parts of the system. Okay. That's meant they allow the single iteration as long as for example, in one module, yeah, for example, in one module, we have two function. The two function need to do, we need we need to adding more, we need to add more, how to explain that? For example, in one module, we need to add more function or we need to do enhancement and our requirement. So in that one module, we can do the iteration together concurrently or simultaneously as long as these two function doesn't intercept each other's function. That's the meaning of this one. Therefore, an iterative approach involves a series of iteration wherein the system is developed incrementally. Yeah, that's mean within submodule you can do, or within single iteration you can do one more than one enhancement. Yeah, more than one enhancement. That's the meaning for this. Doesn't mean for iteration, right? It doesn't mean that one single iteration only allow you to do one change. Yeah, doesn't only one iteration doesn't mean that you are only allowed to do one uh changement to your system. That means you can do or you can allow two or more process together. That's the meaning. For example, here in this version, version 0.2, it's not that only one thing that changed based on this version. That's mean for single iteration to come out with this second version, they allowed to more than one or few changement to this version, as long as the function or anything that the change doesn't interfere or yeah doesn't interfere with each other. That's the meaning. And then we move to next. USDP allowed to free outstanding useful chunks one at a time. Working freestanding. So USDP aims to deliver working free outstanding useful chunks of software one at a time. Useful chunks of a software is like small chunks. You know the term chunks, right? It's like small function or small part of your software. So USDP is the purpose of USDP is to deliver working freestanding useful chunks. Chunks is like small part of your software, one at a time. That's mean they're focusing at one module at a time, or one yeah they're focusing to deliver one freestanding or one useful module at a time. In its example, each of use case may represent one increment of delivered software. Use case, I'm not sure if you know what is use case. Use case is like mm, use case is like a diagram that shows the relationship between or what's the relation between the user and your system. So for each module, I think for this case, the context is each of use case one increment, one of delivered software. I think you guys know what is use case. Use case is use case is the diagram that shows what is the relationship, what is the or how does the user related to your software or project or application. So I think this is not important because they try to relate the use case here with the increment. of delivered. Never mind, we can skip this part. But guys, it's important for you guys to know what is use case. This is the normal term. It's not normal. It's like you will hear this a lot. Use case, use case. So any question before we move on or we go on from there?
So since this one no maintenance, right? So if it's already deployed, means it's a perfect system, kan?
One thing you need to know, uh, correct me if I'm wrong, your question is that we doesn't need to do maintenance after we already implement, is it?
Ah, yeah.
Is that what you're trying to say?
Ah, yeah.
Okay, one thing you need to know, for any process doesn't for any project or process that you do, you need to know that after you already delivered your system to the user, yeah, you already delivered system to your user, even though you already released, this is the final version. Even though you already released this final version that already capture all the users requirement, maintenance still need to be done. There are always maintenance need to be done. Yeah, the maintenance can involve any like mm, the maintenance can involve like any like what's the term? The maintenance is not only involve any changing in requirement, but the maintenance can be involved like any bugs or yeah bugs or any unexpected behavior occur with your final version. So maintenance need in any process or any phase or any model. Maintenance will always be with your system forever.
Oh, okay.
Yes, maintenance. Mm, Usually maintenance can be, based on my experience, usually maintenance can be one of the hardest part for your project because even though you already capture all the requirement gathering, sometimes when the user use your, let's say, your software, they always comment back on you. They want to change so many things. So maintenance, mm, maintenance still need in your project. Okay. So this, okay, this, I think this is the, uh, okay, so I think this is the, okay, this is the activity or process. I won't say process, it's activity in USDP. So requirement capture and modeling. So this is the usually the first phase in any model, requirement capture and modeling. That's mean this is where we gather or where we documented all the requirement. Yeah, all the requirement during requirement gathering. And then the technique requirement assessment use case model prototype. So during your requirement gathering, usually how do you how do I mean using during your requirement gathering, usually they will illustrate, yeah, they will illustrate the requirement, use the case modeling. It's not only for requirement gathering, we there's not only, how do I say, there are no particular or like, yeah, there are no particular diagram that you there are no particular diagram or there's no particular way or method for you or for us to, yes, sabar wait, guys, wait, eh, charge. Okay, so so for requirement gathering, there are no particular atau method for us to use, because in requirement gathering usually it's only involve the what the it's only like the user tell us what they want. So the technique here, the list out is requirement elicitation. I forgot already what's. elicitation, but use case prototyping. That's mean prototyping in requirement capturing is, I think it's quite rare because it's only in the first phase. Unless you have the same or similar model that you can show to your client, you can show them using that prototyping. But yeah, this is rare. And then what is the output from this requirement gathering? Use case prototype glossary, requirement list. Yeah, use case model, requirement list, prototype, and glossary. Glossary is a list. Is I think glossary in this case is a list that is a list what you needed for your whole project or your whole process. That's the glossary for this case, I think. And then we have analysis. After we already gathered the requirement, we need to the analysis for the requirement. So collaboration diagram, class. So I think this is, you know, this. How can we do the analysis is by the diagram, class and object model, analysis modeling, and then we, based on this activity analysis, we will come out with this analysis model. And then after we analysis, we design, design of the system. Yeah, system designing. So deployment modeling, component modeling, package modeling, package modeling. Okay, deployment modeling is deployment component. I'm not sure what is deployment modeling or what's the context of deployment modeling in system design. But component modeling, package modeling, architecturing modeling, that means they are design the system, the whole system, or they break the system into sub-component, or they break into the package, or architectural modeling is, I think you guys can understand from the term here, architecture, are the architecture of your design. So that means you need to design, or you need to write them, or you need to do the modeling for your system based on architectural design. Architectural design, if I'm not mistaken, the based on my previous experience again, architectural modeling is involve the database. That's mean for your for your project and your database, you need to do the mapping. You don't have to understand that, but architectural modeling is, I think, involved with the database or how you design your backend or your database with your system. Overview, design, implementation of architecture. I think this is quite easy for you guys to understand. They're just trying to tell you or explain for each of the process. Class design. Class design, you need to, or usually they will, class design. I'm not familiar with this class design, but yeah, as we can see here, class design, class and object modeling, interaction modeling, step modeling, design patterns. And then they will come out with design models. Honestly, I'm not familiar with this one part, class design. But yeah, I think you can read from here. And then we have UI design. UI design is the how the system, how the interface should look like. And then class and object modeling, interaction modeling. This is all the technique here. This is where prototyping should come. Prototyping is like the early version of your product. But for UI, usually they will show you only like the front end. It's like they show you or they show to the user the your prototype of the system without connection with the database. Yeah, it's like your dummy. We call it as a dummy. Dummy, what now we call it? It's not, yeah, dummy. What's the term? I forgot already what's the term. So yeah, that's prototyping without the database of the system and design patterns. Yeah, this is like I said, design models with interface specification. That means they come out with a prototype that show the module, based on the module, the interface. This is UI design. And then data management design. Data management design, I think this is another phase where they're involved to design the database, DBMS, with the system or with your system. So design models within database specification. Design models within database specification. That means in this process, I think here also, like I said just now, in the architectural design, maybe in the architectural design here, they don't specify how they do the mapping. Mapping is when you're designing a system, right? Mapping is like, mm, let's say you have a system and then you have this database. How do I explain? Mapping is, let's say you have this system and then in the system you have few field. For example, oh no, let's say you have a system or you have this one page. Let's say this one page you have the field, a few field consists of, for example, I'm not sure how to explain, but N is DB. Uh, okay, mapping is like in your front end interface, in your front end, in your front end or interface for any system for application, we have two sides, which is front end and back end. Front end is what we see at the front. Back end is what happened behind the system or behind the system. It can be in your programming or in your database. So architectural design here, no, here, design models with database specification is, um, they need to design how, for example, we call this or we want to save. You learn this already in programming. I'm not sure. Mapping is like how the data or how your DB will capture. Let's say if I key in any name here, let's say if I key in my name here, how the data or your DB will capture this input of mine, and I mean like how they will capture this input of mine and how will they know to store this value into this DB. That is mapping. So we need to design the mapping, like we need to, yeah, that's the term. I don't know how to explain. Like, yeah, for example, I key in this value and then how the data should know where they should store or keep my name, in which in which field they should store. Because in database, I won't touch that, but in database they will have like they store your name based on your this one. So they have many name and then student ID. But then that's too deep. But then that's how database specification, how the front end and your back end should work together. So that's that. And then we move to construction. This is where you're developing, programming, component reuse, database DDL. Programming, I think you know, component reuse is like you calling back your function or you can use any back of your function, database DDL. Connect all the, you connect this front end with this back end. That's in this construction phase and delivered constructed system documentation. Okay, and then we have testing. Testing is usually testing, we only have test procedure, but I think there's still some programming technique need for testing phase, but testing procedure is compulsory for testing and then tested system, the system that already test. Testing system, because I involved once with testing. Testing is not as easy as you think. Last time, I always think that we only test the system if it is already meet the user requirement. But no, testing can be hard too. Yeah, testing can be hard. Implementation. Implementation, install system or do any maintenance after. So we have review question. Let's try this one. A, we can manage complexity versus advanced. No, we need to break into submodule or subsystem. Collaboration, yes. Design, class design. I think this one, yes. Yes. 5. Workflow core is assignment, analysis, design, implementation, test. Only 5. So modeling. Guys, do you have any question before we have 5 minute
No.
break? 5 minute, 11:20. Yeah, can we have 5 minute break and we continue at 11:20? Okay. Uh, so let's continue. So let's continue. So next we will learn about activity diagram. For previous tutorial last week on tutorial 2, I think we already do some exercise or some question using activity diagram. But hmm, let me expand for modeling concept. So for models, the model diagram. So why we need a model in our designing activity? We use model or diagram to provide a complete view of a system at particular stage and from a particular perspective. That means we can see the overall or the overview of our system. Yeah, we can see the overall overview of our system. So each of the symbol or each of the face in our system that we illustrate using the model is represent something. It's either be the process or phase or anything, but it should have meaning for each of the for whatever we illustrate. So what's the reason we use model? Quicker and easier to build, can be used in mission. So this is the reason. I think you can read this why we use models or yeah, why we use model in designing. So this is the reason. You can read it. I think this is quite straight and easy to understand. And then diagram, illustrate or some aspect, illustrate or documented some aspect of a system, abstract shapes to represent things or action from real world follow and standard reason. Okay, I think this is all you can understand. This is the concept, the model, and the diagram. What is model or what is diagram, and why we use model and why we use diagram for our designing. Reason, communicate ideas, generate new ideas, possibly test ideas, understand structures and relationship. Yeah, I think this is easy to understand. So you need to understand this. So first, we have requirement model. What is requirement model? So why we need requirement model? First, we can use to complete view of requirement. Requirement model is for us to have a complete view on our requirement. And for requirement model, we can use case diagram or class diagram. And it include textual description as well as sets of diagram. We will go through this later. And then modeling concept. So behavioral model shows how the system respond to events in the outside world and the passage of time. Behavioral model is behavioral model is, for example, if not for example, behavioral model is okay. Behavioral model is a model that used to show for example, if we have if the user already key in the data or anything that they request, what or how the system or how the how the system will react or how the system will respond to you. Either it will allow you, for example, yeah, in login patch, let's say you key in the right authentication details. So the behavioral model will show how the system should respond or what the patch or what's the next process that the system should show you. For instance, you key in wrong detail or wrong authentication details. So the model or the system will show you that, or they will display like a message to show you that your authentication is failed due to some reason. That is what behavioral model shows, how the system respond to event. An initial model just use communication diagram, include collaboration sequence diagram and stat chart. So yeah, I think you understand here. Behavioral model shows how the system respond to you. And then models in UML. UML is Unified Modeling Language. UML consists mainly of graphical language to represent the concept that we required in the development. Basically, UML is a graphical language to represent the concept. I think you guys can understand this too. UML is, or how the UMS is applied to our process or to our system. Yeah, how the UML applied. Yeah. And then, yeah, and then we have models in UML. This is the UML language, the UML language spot diagrams. I think, what is it mean by here? Graphical language to represent the concept that we required in the development. Graphical language can have, this is the graphical language is something that you shows in, instead of how to say, instead of in like statement, graphical language shows uh how you process for your system in diagram. So there are a few diagram here: use case diagram, activity, sequence, collaboration, class, object, diagram, stage. I think, mm, it is quite important for you guys to know each of these diagram, or how to draw, or how to illustrate this diagram, because I think lah, for your exam they will give you a situation, or yeah, a situation, then they will ask you to draw any suitable diagram to represent the situation based on the question. I think it's important for you to know how to differentiate or how to use this diagram. So first we have activity diagram. So the activity diagram is to model a task by use case. Use case, why is use case? In use case. Do you know what is use case before? Because I think they skip one here, use case diagram. Use case is very common. So have you learned use case in another subject?
No.
Use use case is, like I said, use case is something. Hmm, is this clear? Use case diagram. Use case is quite important for you guys because, for example, here, use case, the purpose of use case is to show what's the relation between, okay, for example, here, this is use case diagram. So this is your system. Let's say you have online shopping system. So this is the customer, and yeah, this is the actor, or this is the customer. So the purpose of use case diagram is to show, for example, here, we take this customer, what the customer can do with your online shopping system. So here you can see they can do four activity, or four, it's not for activity, they can do, yeah, for activity in the online shopping system. First they can view item, and then they can make purchase, and they okay, they can, for customer, they can only view items and make purchase, and they can log in to the system. Usually, this is quite, this one, I'm not sure why they don't have this in your lecture note, but this is important use case diagram. Ay, mak ni time ni dah. Okay, some user. Okay, for example here, this is easier than the previous example. Okay, let's say you have a user A here. They have a system. So what they can do with the system is they can search document, they can log in, they can upload document, they can browse document, they can view events. So use case diagram is to show what's the user or what's the, yeah, what's the relation between the user and the system, or what activity they can perform into the system. This is an example. And then you can see here the second user is like, I'm not sure. Second user here, they can upload document and they can post view and they can add user. I think this is admin. For example, here, this is user, this is admin. So the admin here, they can upload document, they can post new news to homepage and they can add user. So this is basically a use case diagram. You can Google it. I think you can understand what is use case diagram. I think it's quite important and I'm not sure why they didn't include here. But basically that's the use case diagram. So we go back to here, activity diagram. So to model a task, to describe a system function, to represented by a user use case, and to describe the logic of an operation. So this is the explanation, but I think this is not, I think this is the how you're going or what's the element for your diagram. And if I think you're familiar with flowchart, then you will familiar with this. But the only thing that you need to know is, or addition to your knowledge is this part, synchronization bars. Synchronization bars is used to, for example, you have two process that you want. Synchronization bars is, for example, you have two different process, and then you want to join them together, or you want to join or you want to merge the process together. So you're using this synchronization bars, and this is swimlane. Swimlane, as I already explained in our tutorial. Swimlane is like, I call it as a divider. For a diagram, when you illustrate or you draw, yeah, illustrate the diagram, it's actually a one flow. But then using a swimlane, you need to divide them. For example, a system that include these three. This is object. This is people. So you need to illustrate the diagram based on what they involve on which particular divider. I think this you will understand if you do the tutorial. So for example here, I think this is, you are quite familiar with the flow chart here, but for this one, this is the uh, join bar or synchronization bar, or I call it as join bar. You see, this is the use of join bar. If you want to separate to two or you want to join the process, you can use this join bar. If not, then you have many arrow in your diagram. But basically, that's the purpose of join bar. I think this is quite easy for you to understand. Yeah, that's the join bar. And then, okay, what's the use of activity diagram? First, we use activity diagram to model business process at the high level, early stage of SDLC. SDLC is last week system development life cycle. So why we need this activity diagram? It's like for us to get the overall or overview of our process or the flow of our process in early stage. That's mean in, I think this one should be in analysis of your requirement gathering. Yeah. So you need this diagram to show the overall flow of your process. Then that can be used Mozilla as a manual or new computer system. Okay, this is new to you guys. Swimlane. Swimlane is who, where, hardware department, or anything that related to your system or anything that related to your flow. So you need to use the swimlane or the divider to illustrate them. Then set the context with title the activity diagram. For your diagram, you just need to give a appropriate title. Yeah, appropriate title to the activity diagram. And then this is the example of the swim. I call it as divider, but I forgot again. Swimland. Swimland. This is the example of the swimland. For example, here your system involves customer and staff. So this is the process that involve the customer, and this is the process that involve the staff. As you can see, actually, this is what like this is actually still one or still still one process, but they just divide the process according to the people or what involved for that particular process. I think this is quite easy too for you to understand to see. If you're familiar with flowchart, this shouldn't be a problem. This is just a new addition to your knowledge. So this is a swim lane. I think this is another example, a good example. This is, okay, this is a university scheduling system. So as you can see here, a university request. This is a process where involve university, people, faculty. So this is one complete system. I think, I think for your exam, I think they will do the same like your previous tutorial. They will ask you to do to write the activity diagram by applying the swimland. So this is what you need to know, or it's important for you to know who is involved for your process or what's involved in your process, not necessarily person or people. It can be anything, for example, here faculty. So you need to know, or you need to understand the question. As long as you can capture or you can understand what is activity diagram is, shouldn't be a problem. And then you need to know for flowchart, right? You need to know for each of this symbol, you need to know what's the meaning of this each of this symbol. This is basic in flowchart. But the new thing is again here is the bar and the divider. So you need to know how or who involved with the question or situation given. This is another example here, right? This is to involve producing a book. So here, how to produce a book. First, we start. This is the what the author or yeah, where's the author involved in the process, and then you can see after the right chapter, they will send to the reviewer to review chapter. So this is where the reviewer will involve in the process, and then after the reviewer already review the chapter, they send back to the author. So here again, you go back to your author and draw this, and then decision book complete. If the book complete, book not complete. Okay. For example, here, if the book not complete, still here in the outer, and then if the book complete, it will go to the typesetter. And then this is just a process. This is just a flow, but again, it's important for you to know who involved. Can be other, it can be anything or anyone. So important. And then the symbol of each of the activity, your starting, your endpoint too, it's important. Mm, yeah, it's important. And then the model producing a book. Okay, this is the one previously. Write a chapter. For write a chapter, sometimes in your, I think I would say this is a complex one because in your activity diagram, there's another activity diagram for one of the activity, but you need to be very careful in your, you need to be very careful in your exam. If they said like in this activity, please draw another diagram or illustrate another diagram in this one particular activity. So you need to understand the question again, and then you need to, yeah, it's quite complex, but it's not that complex if you understand what they ask, because the concept is still there. They want you to use the or to apply the concept of swimland, the divider. Yeah, usage two, and then what? To describe as a represent by use case. Use case. Oh, we will cover use case diagram in next chapter. So it is used in the phase when requirements are elaborated. So basically, that's activity diagram. Mm, like I give you example just now, the use case diagram. Passenger check in, passenger check in, passenger. To describe a use case check in. To describe use case. I'm not sure why or how. What's the how they relate use case with. Maybe we'll understand in the next chapter. But yeah, you just need to know to use this. This is another example to describe a use case. Yeah, I'm not sure. But yeah, for use activity diagram, you need to know how to write this or how to illustrate this. This is another example. This is another example of for this diagram called RMO. Actually, for this flow, if you only write with like a normal flow chart, it will be a very long chart. But since you use divider, you can see the whole process here. But it's divided based on the person or people or anything that involved. That's that. So the usage to describe the logic of an operation, it is used at low level model depending on how particular operation is carried out. To describe the logic of an operation, oh, this part. To describe the logic of an operation. Low level of model is like low level of model is what's it's not specific. Low level of model, that's mean you're focusing on that one activity. For example, later we'll see. So the model we call campaign to calculate the cost. So this is an example, activity diagram from signatures and activity. Logic. Logic of operation is like to show the flow. It's not logic. What's the term? Never mind. So it is used to describe the logic of an operation. So as you can see here, first we start and then we get first. This is a process to calculate the cost. And then after this one, for example, like this, beta. What's the example? I think if I'm showing you like this, you won't understand how this can be. Is there an example? Stock, let new stock. Oh, hmm, no stuff. Never mind. Because I think it will be quite confusing. Never mind, I explain this one. But I think it's quite confusing because you only see this you only see this, what do you call this now? We only see this diagram in this form. I mean, like it doesn't show you how to apply this in your activity diagram. So we back to this, the usage. It is used to describe the logic of an operation. And it is used at low level of the model. That's mean low level is in one particular activity. So For example, in your overall activity diagram, you have this one activity to calculate the cost. So to calculate the cost, you is I think here the instruction here or the activity here is like more to programming language. But in your activity diagram, you can write anything or yeah, it doesn't specify that you need to use any programming language, but you can use anything that easy for you to understand. But the purpose of this is to show the process, of one particular activity. But the example here they show here is to calculate the cost. That's mean in your overall activity diagram, there's one activity that calculate the cost, and this is the process that calculate the cost for that one particular. You guys understand or not? Is it? I think yeah. Like for example here, like I said, there is one 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 process for this one particular activity, right? Chapter. For the example, just now it can be calculate cost. So the calculate cost is activity. So the example shows or they try to explain what is the usage of activity diagram to describe the logic of an operation. Low level, this means it's specific. So yeah, that's for that. And then this is another one, another explanation, which is more specific at low level. First, they get first, and then this is the if else, the decision symbol. This is trying to explain what's the process actually. Calculate cost. Get first, get cost, get next, overhead. So yeah, they just want to try to show you the process here. And then we move to next usage to model activities to show the activities in the USDP. And then to model the way, oh yeah, activity diagram is used to show, or yeah, I think you guys can see it. The diagram is used to show what's the relation or how it is relate to one another in your development process. For example, here we have okay. For example, here for requirement team, what is the or where do they involve? For example, for requirement team, as you can read here, activity are organized and relate to one another to show how the process or how the activity or how the people are related to one another. For example, here in this process, in project initiation document. So who will be involved is the requirement team. So for requirement teams, what they will do is requirement capture and modeling. They will capture all the requirements and do the modeling, and then they will come out or they will produce this list of output. So this activity diagram is used is used to explain or to yeah to explain what's the relation between everything in your process. The requirement team is involved for project requirement gathering, and then it should produce this output here. So that's the meaning. And then requirement capture and modeling. I think this is all the same. This is all the same. Requirement analyst, they should involve in the project initiation and then candidate requirement, and then they will do this process, and then they will come out with this process. And then object flow, it is dependency between what is object flow. So object flow is a dependency between an object. Okay, object flow is like when you do something or when there is a process in your chart or any process that shows in your chart, it shows the what is the dependency. Let's say, for example, in your chart, it shows I think is a dependency between an object of a class and an activity that result in a change to the state. For example, there's one activity or one process in your diagram. For example, they ask you to key in or to select something, and then the input from your the result from your input object flow is like, wait, okay, never mind. I'll explain this later. But basically, object flow is like dependency between object. For example, activity activity that you done or that you do that change the status of the object. Never mind. Okay, for example here, notation for this object clause, notation of an object creation. So this is your object creation. Let's say you have class name, and then this is your activity diagram. So since this is your class name, okay, for example, the one that I said just now, the change in status is, okay, this is your process or this is your activity. Process or activity, your process is to add new stock details. So bef before and after, how to explain? So this is the process and activity. This is your object notation. So how to explain now? Let's I think the system or this activity asks the user to update the how to say that means whatever you update or whatever you change in this process will update the status of your current result. You guys understand or not? Seems like
Right.
I don't understand how to explain this. That means there's a change of status. That means there's change of status after you already do something. For example, another example, I think what's when user is stock updated. Before, then you change the status or you add something or you updated something, so the status of your stock will be updated. I think you guys can understand. Yeah, I think you guys can understand from this example here. So we move to activity diagram. This is the join bar or synchronization bars. This is the one that I said just now to merge or to split the flow to two or one process. So how we will use this join bar is, for example here, this one is you want to split from one activity. Let's say you have one activity here. Mm, this is just example. If you have this one activity here, and then you want to split them into two different process, you can join this. You can do this, illustrate it by using this join bar. Or another one is the how to merge, into one activity. Yeah, you can use this for adding. You can use this to split or adding activity. So, for example, here notation start activity design, and what's the purpose? So this is the example of activity diagram. This is your starting. This is your activity. This is your decision. This is your end. This is another process. Okay. Alternative notation for branching. That means mm, instead of using this like yes or no symbol, what is the alternative notation for branching? So you can use, wait, activity. Stop to add alternative notation. Campaign to add, campaign to add. Alternative notation. Assign, no campaign. I'm not sure this one. I'm not sure this page. I'm not sure. I'll get back to you guys on this because I'm not sure. But object flow. Two ways to show object. Wait, guys, I think we should, yeah, I think we will stop at this part because I don't understand this part already. And then, but I think for this chapter, you need to, this is important for this chapter for you to understand or to draw, to illustrate the activity diagram. So I think for your, because at the end of this chapter, we have an exercise. So for your exam, I think it's quite important for you because the question will be in this form or in this, yeah, in this form. So I think it's important for you guys to try this exercise. And then for previous chapter, I already uploaded into your classroom the solution for chapter 1. So for chapter 2, you try to see or you try to draw first. Yeah, you try to draw first your this diagram, or let me see. Oh, never mind. Never mind. You try first your this one, this chapter 2. Later on Wednesday, I will upload the answer for this one to see or to understand, to test your understanding on this part. Yeah, we will stop until here. We will stop until here. So you guys, Alvin, I don't understand what is not. The use of case diagram. That means you never use the, you never use any flowchart. You mean the flowchart? The use case diagram. Oh, use case diagram. Use case diagram we will cover in chapter 3. Next chapter. Use case diagram will be covered in chapter 3. We will cover in chapter 3 for use case diagram. So I think we can dismiss. Anything else you want to ask before we end our class? Thank you, class.